Okay, so this video is breaking down polyatomic ions so you can kind of see what to do. So I'm going to go from the formula to the name, and I'm going to go from a name to a formula. And so whenever I'm looking at this, it is an ionic compound, but I know there's a polyatomic ion in it for two reasons. One, I have parentheses being used, so that's a good indicator that there's a polyatomic ion there. So the fact that my formula contains parentheses, it all says, boom, polyatomic ion. But also there's more than just two elements here. There's three or more. So we have calcium, nitrogen, and oxygen. So that's three elements. And so for ionic compounds, that's going to tell me that there's a polyatomic ion in there. So that being said, I need to work it the same way, but I just know I have a polyatomic ion. So as I'm going through this, I'm going to look, and remember your positive charge is always listed first, and your negative charge is second. So the positive thing always comes first, and there's no name change. And so whenever I'm looking at this, Ca, I'm going to go find on the periodic table, it's metal, and so Ca is just going to stay Ca, which would be calcium. So it does not get a name change. Just like for every other problem, it doesn't get a name change. So whatever comes first doesn't get a name change. And then the second problem is going to be, it's this, what's in parentheses. And what is in parentheses is the polyatomic ion itself. And so I can see that NO3 is in parentheses. And so I can go look at my polyatomic ion sheet and find the polyatomic ion in O3. And when I do that, I can find the name of it. And all we do is write the name. That's all we're going to do is just write the name. It's just going to be nitrate. And so whenever you have a polyatomic ion, you just need to look it up. You just need to look it up every time. Okay, so that is how we go from the formula to the name. So hopefully that's making sense. If not, you can pause it, you can rewatch it, you can let me know, and I can try to create more videos. But that's polyatomic ion. So then if I want to go from the name to the formula, then I have to do the exact opposite. So if I have something like magnesium, and then we'll go chlorate, okay? Same thing here. So I'm going to just break it down. So I know magnesium is going to be my positive charge, and this thing is going to be my negative. And so magnesium is Mg, it's +2. It's not a metal with two charges, so I know it's just +2, so I just keep it +2. So there it is. And then I have chlorate. Chlorate kind of sounds like chlorine, but I know chlorine, if it's a negative thing, should be chloride. This isn't chloride, so that means that it's a polyatomic ion. So if it's not something that I recognize, or if it ends in 8, then it's going to be a polyatomic ion. So since that ends in 8, I know it's a polyatomic ion. So then I'm going to go look on the polyatomic ion sheet and look up the formula. I don't have to have it memorized, just look it up. It's going to be ClO3 - 1. So now I need the charges to cancel just like earlier. And so I have a +2 and a -1. So I'm going to need 2 of these guys to give me a total of a -2 charge to be able to cancel out that +2 charge. And so when I write it, I'm going to say, okay, I have 1 magnesium, because that's all I needed was just 1. And then I needed 2 chlorates. Since I needed 2, and there's a polyatomic ion, there's multiple things in here, I need to first do it in parentheses. So it's just like in math class. If you have multiple stuff that you're multiplying or dividing, you can put it all in parentheses and then do it all at once. So that's how you write those formulas.